Hi, I'm Anna.
I'm Sophia.
I'm Melissa.
And our research is called "When Mussels Get Crabby." So in our experiment, we're going to be studying invasive species. And invasive species are a non-native organism that have a negative effect on our economy, on our environment, or our health. So two invasive species that we studied are the Asian shore crab, also known as Hemigraspis sanguinis, and the green crab, that is also called Carcinus manus. And for the green crab, we know that it arrived in America around the mid-1800s, and we know that it came by a boat. And for the Asian shore crab, it was first discovered in New Jersey around in 1988, though we are still not sure how it came to America. And the green crab first arrived in Maine in the 1950s. So in 2006, Aaron Freeman and James Byers conducted a study that provided evidence that the blue mussel is able to adapt super fast in as little as 15 years. They have adapted to thicken their shells when they detect chemicals released by Asian shore crabs and green crabs, and this helps protect them. So what they did is they took 4 buckets, and 2 of them they put mussels from where back in 2006 the Asian shore crabs had already reached and had been there for 15 years. And in the other 2 they put mussels that had never been exposed to Asian shore crabs. So then they put green crabs in one of the non-exposed mussel buckets and one of the exposed for 15 years mussel bucket. And then they did the same with green crabs to see if the changes were only about Asian shore crabs and not just crabs altogether. And what they found was that both types of mussels reacted to green crabs because they had been exposed to green crabs for so long, but only the mussels that had been exposed to Asian shore crabs for 15 years reacted to the Asian shore crabs and thickened their shells. So we wanted to continue this experiment because now the Asian shore crabs have reached the area that in 2006 there weren't any Asian shore crabs. And so we kind of replicated that experiment, but with the mussels from this area. So we used green crab, Carcinus manus, we used the Asian shore crab, Hemigraspis sanguinis, and we used the blue mussel, Mytilus idealis. But in addition, we used ribbed mussels, because ribbed mussels live in the salt marshes where there are green crabs but no Asian shore crabs. So in a way, they're kind of like the mussels that hadn't been exposed to Asian shore crabs back in 2006. So we were interested in seeing what they would do as well. So we came up with 2 hypotheses. The first one being that the northern blue mussels, after having some time to recognize Asian shore crabs, will thicken their shells, even if it's not as much as when they respond to green crabs. And our next one had to deal with ribbed mussels, which is that G. dementia would thicken the shells in the presence of C. manus, but not in the presence of H. sanguinis, because they have not been exposed to this type of crab. And we came up with these 2 hypotheses because we wanted to support the idea that the mussels have evolved since 2006.
So, why does all of this matter? Well, it matters because invasive species such as the green crab and Asian shore crab are hurting the clam and mussel industries because these crabs can easily crack the shells of crabs and mussels and eat what's inside. So, to start out our experiment, we went to a mud flat to collect our ribbed mussels, and then we went to giant stairs, and there's a picture of us with Tupperwares full of crabs. So to set up the experiment, we had 3 tracks. In the first track, we had 3 big and 3 little ribbed mussels and 3 big and 3 little blue mussels. And then we had 20 Asian shore crabs that we split up between 2 containers. And then in the second track, we had the same amount of mussels, but this time with 20 green crabs that we split up between 2 containers. And then in the last track, our control, we just had mussels.
So to conduct the density, or to measure the density, we used a buoyancy test. In a buoyancy test, we use cylinders and we fill it up with a certain amount of water, for example, 300 milliliters. And then each time we did that, we dropped into the mussel. And for the mussel we recorded the size the water went up. So if it went up to 310 milliliters, then we record 10 for that certain mussel. And we could do this because mussels are neutrally buoyant, which means that their shells are the only things that weigh them down.
So we used graphs that represent change between one measurement and the next, well, average change in each group of mussel. So you can see if the bar goes above the 0 line, that means it was increased in average shell density. And if it goes below the 0 line, that's average decrease in shell density. So you can see that for our control group, for the blue mussels, at first it increased, but then for the rest of the experiment, they decreased in shell density. We were expecting to see this decrease because there weren't any crabs in the area. We're not quite sure what caused the increase in the beginning. Perhaps because they were taken out of where they had been living. So they felt the need to build up defense.
And then in this graph, it was green crabs, blue mussels, and we can see that the first day they decreased in size, but on between the last 2 measurements, you can see that they increased in size, and this is what we were expecting because this is how they reacted in the Freeman and Fire study in 2006.
So for the blue mussels that were with Asian shore crabs, we see that throughout the 3 measurements, all they had was a positive change of density. And this is something that we guessed would happen because we know that Asian shore crabs are a predator of blue mussels. And from the experiment done by Aaron Freeman and James Byers, their experiment said that the mussels have evolved. So this is what we thought might have happened, that we thought would happen.
So with our ribbed mussel, we weren't sure what to expect. You can see that in the control, even though there weren't any crabs in the area, they increased drastically, especially after the second measurement. And after the second measurement, they kind of stayed at the same rate of change for the rest of the experiment. Again, we thought maybe this is because they were taken out of their habitat, which was mud flats, and put into a crab trap, which is totally different. So they might have felt the need to protect themselves more.
So in this graph, you can see that between each measurement, their shell thickness increased, like drastically. And we were also expecting this because the ribbed mussels had been introduced to green crabs before.
And for the ribbed mussels that were with Asian shore crabs, we weren't quite sure what to expect. So we see that in the first 2 measurements, it's above the 0 line, so it's a positive change of density. But in the 3rd measurement, we suddenly see a drastic decrease. And we thought that this might be because the ribbed mussels didn't know that the Asian shore crabs are a predator because they aren't normally exposed to them.
So were our hypotheses supported by the data we collected? First off, the blue mussel reacted to the green crab just as it had done in the 2006 study by thickening its shell, which we were expecting to see.
And then we also saw that the blue mussel did in fact thicken its shell in the presence of Asian shore crabs. And so that means that that part of our hypothesis was also supported.
And for our second hypothesis, we hypothesized that red mussels would not react to Asian shore crabs. So even though that the red mussels didn't beef up their shells, they did decrease in size.
So this further supports the idea that mussels are able to adapt very fast. And this is great news for the mussels themselves and the other organisms being affected by these invasive crab species, as well as the mussel industry. So thank you.
Any questions?
Just a comment, those pictures were wonderful. It was such a great way. I found them very accessible, the drawings. And it really made sense and they were beautiful.
I have a question. Did you guys read at all how the Asian shore crabs population is affecting the green crabs population at all?
Oh, no, but that's really interesting. Yeah, I guess there's like competition for food and like space. But yeah, we didn't really look into that. That's really interesting.
You first.
Did you learn or know anything else about the mussel that would indicate why it would have such a rapid adaptation over another word? I mean, you said only 15 years. Is there a reason mussels would be unique in that way, or is that typical in the ocean for creatures to have that quick an evolution?
So no, it's not typical, because this is actually really interesting that they're able to evolve, because most species evolve in over thousands of years. So we're not quite sure why they evolved that quickly. We do think that, like in their genetics, they're already able to thicken their shells, so it's just something that they chemically sense predators, and they learn that this type of chemical comes with predators, so with that sense that they have, they thicken their shells.
Thank you.
Yes.
But you said the Asian shore crab was the one that had not penetrated into the salt marshes yet? Was
Yeah.
that-
Yes.
Okay, but the green crab has been there for how long in the salt marshes, or in some of them?
Well, it's been in Maine since the 1950s.
So what's the expectation for the Asian shore crab as far as its prevalence? Is that something that you guys researched at all, or it's where is that at as far as penetrating the salt marshes in the future? And is that something you guys looked at?
Well, we didn't, and it might be because I think I read somewhere that the Asian shore crabs aren't very adapted to live in the mud, but
Kind of more in the intertidal, rocky intertidal zone.
yeah.
I think we had another question over there.
Well, I was just curious whether your findings led you to more questions, if there's something else that made you curious with the information you found.
Well, I was curious to know if other mollusks could also adapt to new threats as quick as blue mussels have.
And similarly, I was wondering if the reactions are the same for other crabs. So yeah, if we were to continue on, well, we probably will. But I'd like to see the crabs, experiment with other crabs.